Hi everyone, this is MathsForUni. This is question 5 from lecture 13 of our Udemy course, Bridging the Gap to Maths at University. If you find this content helpful, then please consider liking and subscribing, as well as checking out our full Udemy course, of which the link is in the description. The question says, calculate df by dr and df by d theta for f of xy equals sine of xy. First, by using the chain rule, and secondly, by writing f in terms of r and theta. We need to check that the answers we obtain agree from both methods. First, it's worth recalling that we can relate Cartesian coordinates to circular polar coordinates by x equals r cos theta and y equals r sine theta. Then let's write down the chain rules for differentiating f with respect to r and theta. For df by dr, we can get this by doing df by dx, and then we have dx by dr, and the same for y. Similarly, df by d theta is the exact same, but replacing r by theta. Then, to compute these derivatives, we need to first find the derivatives of x and y with respect to r and theta to get these four things here. So let's do dx by dr. These will be entirely using these results here. This will give us cos of theta, and then let's do dx by d theta. That will be minus r sine theta. Next, let's do the same for y. So dy by dr just gives us a sine theta, and a dy by d theta gives us r cos theta. Next, we need the derivatives of f with respect to x and y. So f is sine of x times y, and therefore df by dx is equal to y times cos of xy, and df by dy is x times by cos of xy. We then substitute all of these results into these chain rules. First, let's do this for df by dr. So df by dr will be equal to, putting in df by dx, y cos of xy, and then we multiply by dx by dr, which is a cos theta. Then the next term is df by dy, so x cos xy, and then we have dy by dr, which is a sine theta. In order to check later that this answer will agree with that of substituting r and theta directly, we'll want to write this in terms of r and theta. So let's do that now. We use the results here again for getting x and y in terms of r and theta. So we have what r sine theta for y, and then we have a cos xy, so cos of r squared sine theta cos theta, and then a cos theta. Then we have r cos theta, cos of r squared sine theta cos theta, but then a sine theta. And therefore, these two terms are in fact the same, so we have 2r sine theta cos of r squared sine theta cos theta. Now, let's do the same for df by d theta using this chain rule here. We get, slightly faster, df by d theta is equal to y cos xy multiplied by minus r sine theta plus x cos xy multiplied by r cos theta. Again, substituting in x and y in terms of r and theta so that we can check against the other method later, we get r sine theta cos of r squared sine theta cos theta and then minus r sine theta plus r cos theta cos of r squared sine theta cos theta and then r of cos theta. We can factorise out an r squared because both terms have an r squared in them, as well as this cos of r squared sine theta cos theta. Then what remains is a cos squared theta minus sine squared theta. Now we want to verify that we get the same results this way as we would by writing f as a function of r and theta explicitly and then differentiating those with respect to r and theta directly. So again, f of xy is sine of xy, and then putting in x equals r cos theta and y equals r sine theta, we get sine of r squared sine theta cos theta. Then it's quite easy to perform the differentiation. df by dr will give us, differentiate this with respect to r, so 2r sine theta cos theta, and then we get the same but with a cos instead of a sine. Then similarly for df by d theta, we need to differentiate this with respect to theta, so we have r squared d by d theta of sine theta cos theta, and then we have a cos of r squared sine theta cos theta. We use a total derivative here, d by d theta, rather than a partial, since there is only one variable that we are differentiating with respect to, and this is a function purely of that variable. Then, to finish off, we calculate that we have this thing here as being cos squared of theta minus sine squared of theta by the product rule. And then we have this cos of r squared sine theta cos theta. Now we can check that we get the same answers here and here from both methods. We have 2r sine theta cos theta cos r squared sine theta cos theta for df by dr, and indeed that agrees. Then we have r squared cos squared theta minus sine squared theta with this cos here, and indeed that agrees. We have the factor over here, but indeed it is the same thing. Hence, we get the same answers with both methods. The chain rule method in this instance was indeed more complicated, but there are situations in which it can be more helpful. If you found this content helpful, then please consider liking and subscribing, as well as checking out our full Udemy course, of which the link is in the description. Thanks for watching, and goodbye for now.